like to invite our first speaker, Krishna Upadhyaya. He is the blockchain engineer at Polygon Labs. So he will be taking session on RPC for EVM chains. So please welcome our first speaker, Krishna Upadhyaya.
Thanks, bro. Okay, guys. First of all, मतलब थोड़ा सा फॉर्मल नहीं रखते हैं. मतलब मैं देख रहा हूँ लोग गुड मॉर्निंग वगैरह बोलने में बहुत लाइक यू गाइस आर गेटिंग वेरी नर्वस एंड ऑल. सो आई वांट टू मेक अ वेरी चिल सेशन लाइक आई स्पीक एट कॉलेजेस एंड ऑल. सो आई डोंट वांट दैट कि आई विल जस्ट कम हियर say a few words and you're like बंदा ठीक था सही बोल के गया. Let's make it conversational. Like I'll try to convey some few things which I know from my experience. I'm working in this industry for more than 6 years now. Like I started, I'm a very early, adopter, or what you can say, early age engineer. Right now you can see students starting from third year, fourth year, but I started my Web3 journey back in 2017 itself. So I can share few good experience. Trust me. Okay, this will be really helpful for you to understand and get a new perspective of what Web3 is, what decentralization is. First of all, can I know like my audience, like what? I mean, just a quick intro. So like I just want to gauge like what kind of audience. Like, are you guys students or like work in company, or can we quickly start just normal one? So what do you guys do?
We are second year students in our colleges.
Which college?
MIT from Pune.
Oh, MIT. I'm from PICT Pune, by the way. So, okay, you guys.
Software engineers.
Pune. Srinagar.
Gujarat.
Also Gujarat. Students.
No, we are working in blockchain.
Blockchain as in like you're working in protocol, DeFi or dApps.
Mostly DeFi and NFT.
Solidity and JavaScript.
Yes.
Cool. Cool. And you guys are interested in
DeFi.
DeFi as well. Yeah. Okay. Cool. So yeah, we'll start from here only. So my talk is Erigon alternate EVM client. Hi, I'll give a formal introduction. So I'm currently working with Polygon for almost 3 years, like 2.5 to 3 years now. I work in the capacity of protocol engineer. What do I do? I build blockchain, like not the DeFi protocol. So I'm not a contract guy, but yeah, basics I can cover. But I am more on the back end side. Like how things work, how blockchain actually works. What are the behind the curtain scenes on your decentralized. You say this network is fast, that network is fast. How does that actually work? How network is created? That is my core topic is gonna be. I'm gonna try to explain it in as simple words as possible. I'm not gonna go into complex things. So yeah. And as my journey has said, so before Polygon, I worked for again 3 to 4 years worked for a company, but through that company which I worked for different clients. Blockchain. Luckily, I got my entry in the blockchain world early. It was very lucky entrance. I mean, somebody proposed me, there's a blockchain project, would you like to work? I said yeah, and thank God I chose the right path. Okay, so I'll start first with my agenda. So in the agenda, we are going to cover what are blockchain clients, what does it mean to have a blockchain client, how does a blockchain client works, and like technically you should be able to answer a couple of basic questions after hearing this PPT. I would like this to be more conversational. I don't want Q&A to have it at last. If you guys have any questions, just simply raise your hands in the middle. I can hardly say we are not that big number of people, so we can have a conversation. You can ask, very frankly, इसमें कैसा होता है, how does X chain works, how does Y chain work, what is the difference, Ethereum, Polygon, blah blah. Okay, any question regarding Polygon as well, try to throw. I'll try to cover. We'll obviously see what types of nodes we have. Erigon as a client, then compare it with Geth. I hope you guys know Geth. Otherwise, I'll also cover what is Geth anyway. And then I'll give a quick demo how you can run Erigon, create your own RPC server. Basically you can do a lot of stuff using that. It is very helpful right now. I'm pretty sure you might be using some external clients like Infura, Alchemy. You might have heard about it. Yes. Alchemy, Infura, Chainstack, QuickNode. They can provide you with a link. You add that link into your code.
Yes.
Do stuff. So I'm gonna show how does that link thing work backend, and you can create your own maybe. If you are working for a company that's a small startup, then you might not need to depend on these guys. You can create your own RPC servers very easily using Erigon. Okay, like literally your own. Like nobody cares how much requests you are throwing at it. Okay, blockchain clients. So first of all, let's start with quick conversations as well. So when you guys say DeFi or dApps, do you guys really? Both we have D in both of them, right? We know what the D represents. D represents decentralized. Is your app decentralized? What makes it decentralized? How does your dApp is a decentralized app? Like, what makes it decentralized?
Peer-to-peer.
But you are deploying it on a contract, right? So how does it make it decentralized?
The blockchain.
Right. Yeah, exactly. So the blockchain, the thing behind that application is actually making it decentralized. If you deploy your own app in your laptop and say I wrote a contract in Solidity and this is my interface, let's say on your own local dev, that's not a decentralized app. That's a local app, like simple app. Okay. So what we are making is again an application, but if it's decentralized network compatible, for example, if you make it EVM compatible, that's a EVM decentralized app. Like we are deploying out of any chain which can support EVM. So that's what the D in the decentralized means. A lot of people think that if we write a code in Solidity or if we write anything related to Solidity or something like that, that makes it decentralized app. It's not like that. When you deploy it on a decentralized network only, then it's gonna make a decentralized application. That's already true. That's why there are questions. Is this really decentralized? Because if your network which you are deploying it's not decentralized enough, then it's not a decentralized app itself. So you have to understand what the decentralized word means. Decentralized word, like the most important thing to make anything decentralized is blockchain clients. So when I say client, in simple words, I'll keep it very simple. Clients are the one who are actually gonna make your network decent. The more clients you have, the more decentralized your network is. What I mean by client? So assume this analogy when you are running a car. I mean there is an engine, right? So obviously nobody gives a shit how cool the engine is looking or how beautiful it is. Like nobody says my engine is really beautiful. It has grey color or white color. But people talk about numbers. Like horsepower and similarly in blockchain world, the clients are kind of acting as an engine. They run your chain. Run your network. Like if they are not there or if they are not working, just like engine is not working, your car will stop. No matter how beautiful your car is, it will stop if the engine is not there. Similarly, if the clients are not there, if the clients are not working properly, your blockchain will stop. So your decentralized app is still there, but the blockchain has stopped. So technically your network is not going to work. I mean, you cannot do anything with that. Just set it with it. So similarly, clients, you can I'm not sure great analogy, but yeah, you can understand it like that only. So that's why you need different, multiple clients, multiple people to have more decentralization. When we say we want high decentralization, there should be multiple clients. That's what I'm trying to encourage here people. Like right now, people just think, okay, let's use this, particular RPC URL and all. And imagine if only 2 or 3 people are controlling the whole network, or if only a couple of, a certain number of clients controlling the whole network. Is it really decentralized? You want options, right? Like it's not bad to have options in decentralization. You have multiple options, it's better. So currently, as you are looking on my screen, there are a couple of logos. I'll come to that part. As all these logos basically represents famous clients which work on Ethereum. So as I said, clients means, I mean, when you say that the block is getting created, a network is getting my block is getting mined, or a new block got created and this has come, that and so whatever is happening on the blockchain, when you say that merge has happened, fork has come, everything is happening in the client. Now there is no app over there. The backend system works on client. So client is a piece of software which provides you P2P network as most. What is P2P network? Like connection between different clients. So if you, let's say if I'm running one client, you are running another client, it should still be able to connect. It's not like that my client is X and your Y, so we should not be able to connect. Because in one network, if I'm following a single client, then that client should follow the network's consensus logic. That's my second most important. Consensus logic means that a network has a certain set of rules. If you are running Ethereum, we have these 5 or 7 rules. If you follow these 7 rules, you are a part of Ethereum. If you break any single rule out of these 7s, you are not a part of Ethereum. Doesn't matter what you do. So if you write a piece of code which can follow these 7 rules of Ethereum, then your code is a client. Okay? If your client, it's not like that your client should provide all the functionalities which a normal client, like if your client doesn't provide mining, that's fine. If your client doesn't provide security, that's fine. I mean that's up to you if you don't want to use a security. But consensus is a must, and the consensus is the first thing, and P2P is the second. Because if you don't provide consensus, then technically you are not eligible to be part of the network. And if you don't provide P2P, how will you connect to the network, communicate to, how will you verify your consensus? So does this make clear clear image of client? What does a client mean? How you can explain it? Obviously after that there are certain optional things. For example, fork choice. Fork choice is basically how you depend. How do you decide which fork you want to decide on? Like if you have a like you guys know reorg and all. Like we recently had a merge and all. After that there's a ETH POW chain and there's a ETH POS chain, like new chain, and like we earlier also had Ethereum Classic, Ethereum. What is this Ethereum? Like when I was young, I didn't know what is the difference between Ethereum Classic and Ethereum. I think Classic is better. Let's buy that. But later I came to know Classic is not good. The actual Ethereum is good. So the difference between these clients, they are completely using a different set of logic. Their consensus is different, and that's why depending on their consensus, they have decided, they have chosen a fork. That basically there can be smaller forks which we call reorgs, like a smaller reorg has created a chain, but there are bigger number of. For example, Ethereum Classic is nothing, or Ethereum is a nothing, but a fork from Ethereum Classic happened at a certain block number. So if you go beyond that, like before that block number, you will find that Ethereum and Ethereum Classic has same state, like same data. Like, but after that number, they basically created a fork. So that's why fork, like the fork which we eat at. Similarly, like that's how I understood. So that's why your client should have a fork choice rule depending on which node you want to run, which network you want. Let's say, for example, when merge was happening, if I wanted to stay with Ethereum POW, like the POW. So I could have chosen that fork rule, that client, that okay, I will stay with POW, and my client would have worked like that. So that's why your client should have a fork choice rule. State management, obviously, I think this is the one of the easiest. State management, as in whatever transactions you are doing, whatever entries you are putting in, whatever data you are presenting, it should be able to handle all the state management. Because if your node is still consensus, imagine like this, your node has consensus logic, your node has P2P, but it's not able to manage your state. I mean, that's more important for you guys, like you write contracts. So whatever you're writing in contract, you're updating the state. Basically, clients are someone who are running the chain, maintaining the state, and dApps are something which are updating the state. See, clients don't update state in general, like in rare cases they do, but in general, the dApps are the one who actually update the state. So when you say you are running a decentralized application, basically you are updating the database or you are updating the state in a decentralized network. I mean, imagine in a normal situation, I'm not sure how many people have worked with SQL or MongoDB, like centralized databases in the courses. So in that, you are also doing the same thing, but you are doing a server. Like you hit a one post query and you update it. And it updates in one record. Like if somebody has access to that server, for example, I got ID password of your server, I can go edit and do whatever. Like if I got access to a bank balance server, I can make my balance 10 crores and yours, and nobody gonna give a shit. I mean, nobody gonna check, like, because there are no limitations. But here every state is connected to each other state. So when you are doing state update, when you are still take state management, everything has to get recalculated from the previous one. Like if you are getting 10,000 as input, it must have come from somewhere. But in normal database, I think we can do easily. I'm not sure there is any kind of check on all. Like very simple without security check. The block gossiping basically, again, decentralization. So if I don't do block gossiping, how I'm gonna let people know that I've created this new block? When we say that a miner has mined a block, what does it mean? We mean that a client who is running, let's say I'm running a client on my local server. If I mined a new block, so that means I have to tell the people, like let's say all of you are a client and I'm the one in the network currently as a miner, acting as a miner. This is my turn in the POS network. So I have to mine the block and I have to gossip, tell everyone that hey, this is my block, this is my block, this is my block. And if I don't do that, you guys will assume that I'm kind of dead or I'm not doing my job properly and somebody will take over me, right? So block gossiping is important for mining purpose. If you don't do block gossiping, your P2P network basically get hampered. Like if you're still connected to via P2P but you don't do block gossiping or even transaction gossiping. If I have you are using an Infura RPC, okay? If you submit one transaction to Infura, but Infura's node doesn't do transaction gossip or block gossip, how you are gonna get? And if there's a miner sitting somewhere else, it's not Infura's miner, it's some XYZ miner. If your Infura node doesn't tell that miner that there's a transaction in transaction pool, it's somebody XYZ person has sent this transaction, the transaction will sit idle. You guys might have seen this situation where some people complain, that it's almost 10 minutes or 30 minutes, my transaction is not got mined or it's not getting, added into any block. The reason is most probably like either you don't have enough gas, one reason. Second reason, your transaction pool is not getting synced. So, transaction pool is basically a bucket where everybody, just fill their transactions randomly, and if these buckets are synced, let's say my bucket and your bucket are similar, like whatever you get in your bucket, you convey to me, gossip to me as well, then only I'm gonna pick that. If you keep that transaction in your bucket only, how I'm gonna pick that? I don't even know that transaction exists in another. So that's why block gossiping or transaction gossiping matters. And yeah, transaction gossiping and handling obviously. Second thought I think I already got. And the last, security. I mean, technically,
that transaction pool, is it also inside the? Is it also
yes, in the
part
client.
of the
Yes.
client?
There's a mempool called memory pool, transaction pool. So every transaction goes, whenever you're submitting to a transaction, you're submitting to a node only. You're not submitting to the whole network. So there is only one node sitting behind your RPC. You always submit to one node. Then that one node's job is to communicate to the 1,000 nodes in the network very quickly. And that happens via blocks gossiping and transaction gossiping through P2P network. So first I have to establish connection. See, P2P is the base part. Like I have to establish that I should know that there are X, like if peers, you guys might have heard peers. So what is peers? Peers is basically the nodes I'm connected to. So I'm connected to 100 peers, I'm gonna gossip to them. Then they are connected to 100, then they are connected to 100. So that's how the network, I think within milliseconds, get propagated if my network is working correctly.
And what under the hood protocol used to peer-to-peer? net, like that communication is at the network level.
Yeah, that communication, same technology that torrent and all everybody knows, like we directly basically create seeds and all. We communicate through network IDs. That okay, this network is there. This is my communication. There is a certain port over which we do handshake and pass data. So yeah, there is a whole P2P. That will be too detailed to cover actually. But yeah, there is a whole P2P similar to torrent. Which torrent uses earlier. So we took the same network, like communication with peers, multiple peers. Torrent people might know about peers a lot. मुझे peer नहीं मिल रहा है. Okay, security is very important. I mean, technically, it's why I put it last, because it's something of, let's say, if you want to do a non-secure client, that's up to you. But security is important because when you are running a client, you are actually part of the network. Okay, so if your network is compromised for some reason, let's say you are a miner and your network is compromised, technically a certain part of the network is compromised. Right? If your network is doing false transactions, then it can actually hamper the network. So that's why security. I majorly mean when you are a miner or even when you are not miner, security as in here comprises that nobody should have access to your node unprotected in an unauthorized way. If they want to do something, they should sign it properly. Like, imagine if you are a good you're a miner and some unauthorized transaction has been able to reach out to you. You should manage that kind of situation as well. There are multiple security aspects, like whatever security vectors are there should be covered in your client as much as possible. There should be no loophole that okay, if you are running XYZ client, I can basically do a certain kind of message, throw certain kind of message, and make your node run out of memory, like OOM attack, out of memory attack. So these kind of issues should have been identified. So okay, so I think I've talked a lot about clients. So by the way, these logos are 4 famous Ethereum clients which are currently in the market. The left one, which is like a minion, is the Go and Gets logo, Go Ethereum. Yeah, the foundation. Foundation. This is the most used client used. The right side is Erigon, which is my topic technically, but it's the second most kind of neither mind and Erigon are like the second most, like 2 or 3 number, and the Bezu is something less used because even I don't know what the difference are, but yeah, there was like this thing, so I added it. But yeah, neither mind, Erigon, all these clients are EVM compatible. All these clients give you these these properties which are mentioned on the left side.
Neither mind is the second one.
Yeah. Okay, bro. No problem. Neither mind second, Erigon third, 1 or 2% here and there. But yeah. Okay. So when you are running a node using a client, you have to understand the difference between the node. I mean, it's not like that there is one client and there is only one type of node. Okay, every node serves its own purpose. Everybody doesn't have that much of bandwidth, or that much availability that I can run each kind of. So there are technically 4 nodes, out of which we are going to cover 2 in detail, full and archive, because these 2 are the most famous and used amount of nodes. Light clients is something I will say still people are working on it. I will still say they are not that practical in the current tech set of technology. Basically, light client, I'll go into detail, full and archive in the next slides. I'll explain the light and stateless in brief right now. So the light clients are basically, imagine this situation where you don't have to you have a blockchain node running in your mobile, or even a very basic simple device, where you want to verify something and you need minimum data and you just fetch it, you just have it and minimum that, and you can verifying a transaction on your mobile itself. So these kind of clients here, people are trying. I'm pretty sure right now as we are speaking, there are experiments happening, there are developments happening, people are writing, discussing, but I'm not sure any good or very popular used light client as of now. But it's something which will for sure come in future. Like next target for the Ethereum community is to bring Web3 to your phone, to your watch. Like simple, like you can simply check mine your ZK knowledge proof. We are hearing a lot. So with ZK we are trying to bring ZK through light clients into your very simple provers and in your phone itself. But that is something still work in progress also. Similar with stateless client. But right now the full and archive nodes are the best nodes to go. So they have their own purpose. We'll call in detail. So full node. Basically, earlier initially when the blockchain started, obviously nobody thought how long it will go or to what extent it will go. Like millions. Right now we have millions of blocks in Polygon as well as Ethereum. So yeah. So right now the current full node setup looks like this. So if you go to the right, assume the G is the genesis and there are blocks getting created. So a full node is a node which has history of last X number of blocks present in it. It depends chain to chain. So for Ethereum, I guess it's 128 blocks. For Polygon, it's more than that. It's 90,000 or something. I'm not sure. You can change this number. Obviously, it's configurable. But yeah, basically you have last X number of blocks in your memory only. So if you query anything of like let's say right now I'm at 1 million and it's like the number is 1 lakh. So from 9 lakh to 10 lakh, like 9 lakh to 1 million, I'll have all the data, all the history of the code. But below that, I will basically prune the history and the data so that I can save on the number. So that's why the tracing ability. What is tracing ability? Tracing ability is basically if you want to trace a particular transaction, like there's a transaction which went from X to Y, Y to Z, and basically how it went through the network. What are the things it updated? What are the values it updated through the network? So if you fire a transaction, it could be a simple transaction from X to Y, or it could be a very complex transaction of multiple contracts involved, multiple parties involved. So if you want to trace these kind of transactions, you need all those data, right? History, like okay, this happened, that happened, that happened, this happened, that happened. So for that tracing availability, you need like if your transaction goes beyond that data, like I want to trace some transactions of 6 months old, like 6 months back something else. So I will not be able to do that on full node. Reason behind full node doesn't even have that set of data which I'm looking for, or which I'm trying to trace for. Full node will say, this is the current status. I don't know what happened, how it came here. I'm sorry, I don't know. The full node will say the balance of this guy is 500 Ethereum, whatever. I don't know where this 500 came from. Full nodes don't have this data in detail, like how that 500 came in, where it came from, who minted it, and whole history. So that's why they have like usage when you are running, when you are running something that you don't know. Like let's say I'm running a miner. So in miner, I don't need whole data. Like if I'm a miner, I already know that I have verified the older data. If I have the recent amount of data, I can continue building. Like let's say I want to build n plus block. I only need n block. If I have n block, I'm going to apply the state on n plus states of n1 and compute the hash, and I can mine. But I don't need block which is older than 1 lakh block. Okay. So for these kind of purposes, where you don't need very older data, or you need a specific number of data. Here I only need a plus 1000 block or 5000 block or 1 lakh block. You can run your own full node and still do whatever like RPC query. You can do tracing and all. But if you ever come in a situation where you need older query, you want to do older query of balance, or you want to know history or tracing availability, then yeah, it's not recommended to run full node for your debugging purpose or analytics purpose. Because analytics, when you are doing analysis, I want to do analytics on a particular account, I cannot do it on a full node. So that's the problem with full node. But advantages, obviously low running costs, since you are running a node which doesn't have that much storage to do. Obviously the storage size is comparatively very less. The archival nodes goes into terabytes. Full nodes usually run in megabytes itself, gigabytes, not megabytes. So yeah, like I'm pretty sure 300-400 GB is enough for a full node. Wherein if you look at archival nodes, I'll come in. It's in TVs, multiple TVs for multiple networks. Less storage required, as I said. Yeah, in running cost, as in your PC and everything will also be lower because the costs are running. The queries will be lesser intense. You are not going to fetch those deep amounts of data. Not going to trace those deep tracing availability is not just your cost is going to be less. And important thing, maintain. Why I have mentioned this point. See, everybody now that we are talking about decentralization and this start. See, everybody cannot run the whole blockchain on their own. Like why I added this point, maintain decentralization. Because if the full nodes are not there, assume this situation, if the full nodes are not there, how many people in the world do you think will run archive nodes, which have terabytes of data and need 32, 64 GB of RAMs and all that, like basically high computation. Not everybody can do that, right? You cannot run an archive node on your laptop. That's very hard to do it. Okay, so that's why I personally think that still in this world, 70 to 80% people who are running nodes are actually running full nodes only because they only have this much amount of requirement. Like they need only decent amount of data. Like agar last 1 lakh blocks if they get the data, like if they're happy with the data of last 50,000 or 1 lakh block, then they are fine. They said okay, we don't need more than that. We already trust that the older data is verified. Okay, so that's why full nodes are very important for maintaining decentralization of the network. If the full nodes are not there, I personally think the decentralization will get hampered. Okay, because yeah, everybody will not run. Now we are coming to the archival node. This is main. That's where like archival node. Why I'm highlighting in this because this is where the Erigon client comes into the picture. As I said, Erigon, like alternate EVM client. I basically means Erigon is very good compared to the competition. Like we have already have Keth, we have Neithermind, we have Erigon, we have Besu. But where does the Erigon shines? What is the importance of Erigon? So Erigon shines where the archival nodes comes into picture. I'll explain why. So first of all, let's explain what is archival node. Archival node like store all the data in Genesis. Like it has everything. It doesn't even skip a single block. So when you are running an archival node, it has every information from what happened to Genesis till right now. If you want to trace anything, like as I said, history of every state change. So whatever has happened in history from day one. Like if I'm running an archive node, I can check from block 1 to right now what has happened. I can use it for analytics. I can create a map out of it. I can debug whatever situation has happened. Like any situation for which you need every stage of data, the archival nodes are the one which you have. Obviously, full tracing capability, as I said. So full tracing capability, again, you can check whatever you want, whatever history this particular account. For example, smart contracts, you can even check where this smart contract got created, what state it created, when this created, what was the situation and all that. That everything can happen only on archive node. Full node cannot provide that. That's why the name archival node. That's why if you see on the right, all the blocks are in orange. That means it has every block since inception, obviously. And best for serving RPC requests because if you are serving RPC request on a full node, it is possible, highly possible, that you might miss out on certain amount of data. Like if I'm querying anything for Ethereum's case, it's hardly 128 blocks. So 128 blocks is not that long of period. So if you are running a full node on Ethereum and if you are querying anything older than 128 block, let's say like a day, like what happened last day, you might not get the data on the full node because full node doesn't have this capability to provide you that data, but the archive node does have it. But there are certain disadvantages. Obviously, the running costs are high because you need more infrastructure, you need faster infrastructure. I mean, the RAM and all, because you are processing all that data, and whenever you are processing data, you are doing more computation. So because of more computation, the initial cost is high. What I say is, it's not like the running cost is high. Technically, after a certain point, they are doing the same job. But once you start the full node, it skips the older data, just follows up, the latest. But when you are running an archive node, where it's syncing from scratch, it's recalculating everything from scratch. Like it's downloading the Genesis, calculating the hash, one Genesis hash, and so on. So the initial cost, you might need more higher RAM, higher processor. Like in personal experience, I've seen the more the RAM is. I mean, in case of Erigon, it's IO intensive. So the more the RAM is, the faster it is. So that's why you need a higher running cost. And yeah, more storage is required. Reason behind simply, since you are storing everything from scratch, all the data from Genesis block to the n-1 block, you will need more storage. That's pretty simple, clear. Okay. Any questions? Sorry, I might have spoken too much. Full node. So you guys understand, because I'm coming to the point. So this is just to set the context. We know what a client is now. We know what kind of nodes we have. Now we will know how to set up our own node. Like simple step. How are gonna, like if I said in the start. After the end of this pitch presentation, you guys will be able to have your own RPC servers locally for your development purpose if you will do. A small team can literally easily do that. You can run on your laptop as well. Like for some networks you can do it, like for Mumbai, Polygon or Borley or Sequoia, you can run these clients literally on your network. The numbers are as low as that. Okay, so yeah, let's coming back to the Erigon. So execution client and efficiency frontier. What I mean, so Erigon is nothing but so Geth was there. So what happened someday? A few blockchain developers, engineers thought that okay, Geth is there, but it's doing few things which are not very optimized. Like not on the very efficient. Okay, so Erigon Geth's job was to do a lot of purpose. A lot of things like mining and gossiping and everything. Geth has multiple jobs. So they thought, why don't we just take out fork out Geth and first of all develop a piece of software for this archival purpose only. So the Erigon was born only for archival purpose. It was not supposed to act as a validator. It was not supposed to act as a full node. The birth of Erigon was on the principle of making it efficient node on archival nodes. Like the purpose of Erigon was to give people a better and cheaper and smaller archive nodes. So right now, I'll come to the numbers later. But if you look at comparison between Erigon and Geth node, when it comes to archival, you will see the numbers, they are very big, the gap.
It reduced by 4 TB.
4 or 5 times.
4 TB.
Yeah, even in Erigon 3, I've heard, new version Erigon, just giving some alpha, they come out, they are gonna make Ethereum archive node in less than a TB. Okay, I'll come to the numbers. I have some numbers, I'll come to that.
So, how do you do that?
They are compressing snap. Basically, they don't want to store that much. They think the idea is to regenerate as much data as possible rather than storing everything and still giving all the tracing and everything. See, what is an archive? It's not evident that you have to store everything. The general purpose is you have to present everything. If I ask for X amount of data, X data, and even if it's older, you should be able to present. It's not required for that to be present. Maybe you can regenerate it. And if you can find some algorithm using some ETL process something, using which you can generate it on the fly very efficiently, like milliseconds, then it's still an archive node and still your
but there should be some data which you can
so that's where that's what I'm saying. Like it's gonna come with Erigon 3 right now with Erigon 2. I'll come to that. Erigon, see, I don't work for Erigon, but I work with Erigon for a long time now, so I can give you some alpha. Obviously, I cannot discuss because even Alexi, the CEO of Erigon, I talked like yesterday. I only had a call with Alexi. So he didn't told me how it's gonna happen, but I can tell you they are gonna do very big stuff. So for Polygon, currently the terabytes, the numbers in terabytes are like for normal Geth node is 40 terabytes. If you do it in Erigon, it's 8 terabytes. In Erigon 3, they are saying they are able to do it in 3 terabytes.
Means you are compressing the data somehow.
Yeah, so we are also waiting for full updates on that, but still we have a good numbers, and I'm coming to that. Let's say we can discuss on numbers in next slides. We have. So the idea was efficiency frontier. Basically, we want to make archival nodes efficient. That's why I said archive node by default. I mean, when Erigon was implemented, the idea was not to give a mining node or not a full node. The only idea was initial idea that let's give people archive node at a very low cost, at a cheap cost, so that they can do their development purpose, the infrastructure. See, if there are, let me make this clear, if there are no archive nodes, there cannot be any development. Guys, whenever you are using any RPC call, whenever you are using any RPC server, there is an archive node running behind. If we eliminate archive node from this decentralized world, you cannot do development. For development purpose, for implementation purpose, you need archive nodes. So that's why archive nodes are that, like most of the people don't understand. 80% of the Web3 world doesn't understand the importance of archival node. It's very important to have the history to trace it. Otherwise, anybody can, people can basically play with it if you don't have the oldest. What if I have the control of the network for a certain period of time, but not the whole, time? So security also gets compromised if there are not enough archive nodes in the network. So what Erigon did, like coming back to the Erigon, so what Erigon did different is Erigon has the staged sync procedure, which I'll explain later in detail. But the brief is they basically broke down the whole, the flow of how Erigon Ethereum syncs, and created a staged manner where rather than syncing every block or everything in one go, like syncing one block, two block, they basically rather going on the process. Okay, header, like they basically broke down the process into header phase, body phase, transaction lookup, account lookup, and execution and hash calculation. So they basically created multiple stages, which I have explained more detail in the next slide. I'll come to that. So they have this stage sync procedure that compared to Get's normal syncing, they have this new way of syncing a node. It's different. That's major one difference. Second difference, they have flat data structure. So if you know blockchain, always you might have thought that the only way of making blockchain possible is trees and all. It's not like that. You can obviously make it via trees, but there are ways of storing trees in flat database structure as well. Obviously, you must need some ETL process to extract the database from flat database into the T format. Ultimately, when you verify, you have to present it as a tree. But when you are storing, you can still convert that tree into flat database structure. And when you store something as a flat database structure, the footprint gets reduced significantly. I mean, when you have a key value pair, the footprint gets very low compared to storing the whole tree in one block. Okay, so that they have a flat database structure. I'll come to that in detail again. So highly efficient RPC handler, that is one of the most important parts. So the goal of Erigon was to, as I said, archive node. And what is the most important application of an archive node? RPC handler, like connecting people to the node. Like if I'm running an archive node and I'm not letting people connect to my node, there is no purpose of having an archive node. What is the purpose? See, I want people to query my node, get whatever data they want, get older data, debug, tracing ability and all that, indexing ability. Like they can fetch, like let's say you are running an indexer from zero, like I hope indexer you guys know. So if you are running an indexer, you need data from scratch. Like you cannot just enter an indexer from right now, like 9 million or 10 million. You need data from zeroth block. So for indexing ability and all this, archive node is required, and for that RPC handler is required. Like how are you going to query that? You're going to query data via an RPC handler. That's why I said, if you look at my top topic, it's like Erigon alternative RPC client for EVM chain, because if you're running a Geth node or if you're running any other node, you don't get that efficient RPC handler. Erigon's highlight of the network is it has the best efficient RPC handler, one of the lightest footprint in which it can sync the node, and that's where people like Infura, Alchemy. I'm not sure you know the behind the scene, but if you look at Infura, Alchemy, QuickNotes, any infra provider, most of them are running Erigon right now for their RPC purposes. I mean, I'm pretty sure I can say 50% of Infura or 50% of infra is provided using RPC node as of now as we are speaking. Even with Polygon, I personally know a couple of guys like Anchor and Infura and ChainStack. So they are more interested in having Erigon as their RPC client rather than Bore, because Bore is good for mining. When I say Bore, I mean Polygon's execution client like Geth. So rather than having Geth as their execution client, they are more interested in having, because they don't have to do anything with mining, right? Infura is not a miner. Infura is an infra provider. ChainStack is an infra provider. So when they are providing you RPC requests, they have to handle millions of RPC requests in minutes. Like they get, I'm not sure, million or billion requests in a day. So when they are handling millions to billions requests in a day, they need more efficient RPC handler. They need lesser footprint. So that's why Erigon is very high, highly efficient RPC handler. How? I'll explain. I have slides for that as well. Reduce disk space usage. It has a smaller disk usage. I mean, comparatively, the numbers are very less. Multi-chain support. That's one of the best thing. I'm not sure how many clients does that. So Erigon supports. Sorry guys. Sorry. So Erigon supports Ethereum. Erigon supports Polygon. Erigon supports Gnosis chain. So there are 3 chains which indirectly it supports Binance as well. But what happened? Like there was some issue with Binance guys that their consensus, their system was not getting fitted into the Erigon's roadmap. So it officially dropped the support for Binance. But still, you guys can find out online that there are some, they forked out Erigon. Basically, the people who wanted Binance support, they forked out, and they are still maintaining a Binance fork for Erigon. But officially, from Erigon team's perspective, they are looking at Ethereum, obviously their first priority. Second is they are officially partnered with Polygon, so they are also looking at Polygon's roadmap and trying to merge, whatever system changes we are doing into their system. And they are also supporting Gnosis chain because they are funding them as well. Okay, I think I have taken a bit time in the initial, so I'll cover these stages a bit fast and come to the demo because I have a demo to show you guys as well, and I think I'm 20 minutes left only. So yeah, stage sync is basically we re-architected the guest full thing into stages, as I said, multiple stages. So rather like if you look at normal nodes, it's synced it like, sync block 1, sync block 2, like they sync block wise, they sync block 100, then they sync block 101 whole. Like they take one and like let's say I'm a syncing node, I import 101 block, I go through its headers, I go through its bodies, I go through its transaction, process everything, create, calculate hash and everything. And all the work I have to do, I'm doing it in one go, and then I add it into my database and say, okay, I'm done with 101. Rather than doing that, what Erigon did it, rather than importing every block in one thing, they said let's divide the process into parts. Like for headers, so what they do is they download only headers for block 101 to let's say 1 to 100. So they download headers from 1 to 100. And when you are doing this, you actually save time on efficient or calculating part, because when you are downloading, rather than downloading body and see when you are processing that 101, you are actually wasting some of your bandwidth in downloading part. You can basically process it later and still download the data first. And even when your node is offline or not connected to enough peers, you can still process it, because if you have enough data, I have all the headers, if I have all the bodies, if I have all the transactions, I can still process in the background. Okay, so that's what Erigon is doing. Rather than wasting time in downloading, processing, then downloading, then processing, they are just downloading, and then processing the whole everything in one bunch. Not exactly one bunch, but in multiple processes. So initial stages, as I said, 17 stages are right now here. So initial 1 to 5 stages are network dependent. In the 1 to 5 stages, they download block, they download all the mappings, and from 6 to 17, they do all the processing. When they are doing the processing, it makes it fast. Parallel in stages and use the support of ETL. As I mentioned in the last one. So what they do is they do some pre-processing using ETL. Using that they convert this whole structure into flat database. And they are doing this in their background. They are basically as well as making it faster. As I said, it's IO, more RAM, your network will sync more RAM you have, the more faster, because it's gonna add the data processing in the background. Extract, transform, load. There's an ETL processing running in the background using ETL processing. While the process whatever data is processed, they are basically putting it into the database. So that makes it very efficient and faster, and also the RAM. So that's one advantage. Where did they download it from peers? Initially, so that's rather than downloading processing, they do the downloading more. Let's say my network is 10 million, download the whole 10 million blocks in one go and store it as a file, as a yes, initially. But you said as well, like if it is stage 7 is execution. I can provide you links where you can read about these stages. 7 stages execution. So in the execution, they execute the block. If they find any discrepancy, the hash which is generated, not the hash which I got from the other player, or they basically rewind the block and try to download that particular block again. Multiple peers. Yes. They have there is one snapshot thing as well, where they have state snapshots loaded by Erigon providers in the current. They can use that as well, but that is available there as well. Okay, yeah, executed in order. As I said, supported logs and obviously, as I said, if there is an issue, if there something goes wrong, they have options to handle relog as well as unwind. Say if I have downloaded a log which is not there, relog cannot rewind my stages like the same order, reprocess it again. Yeah, they process it with the. So what I will do is I'll share a link. This case sync has very good details. I'll show it like you guys can read what are the stages and how it works. Yeah. Very important part. JSON RPC tables. Most important part, as I said, JSON RPC. So see, there is one thing having your node. So when you are running a node, or any node for any blockchain, there is one RPC handler inbuilt in your node. If you are running Get, you have one RPC. Node is running as well as 8545 port by default on which you can do RPC query. Simple. In normal, even in Get, even in Erigon, but I was hoping similar stuff. But in Erigon, there are multiple RPC process itself has separated as a daemon is basically a background process, a separate process which can run from the main client as can run the client. Look at the image. The Erigon is running a single process. And default option run Erigon. Default RPC attached to one RPC inbuilt into the RPC. If you just need one RPC, that's fine. If you want your infra providers, big providers, if you run what they do is they run one Erigon node. It has the database, everything. On one single Erigon node, they can attach multiple RPCs. What's happening in the image? There is one DB as a database which has data directly. There are multiple RPCs, R1, 2, 3, 4, 5. My only what's happening here is I can still handle, like, let's say if I can handle a million requests on one RPC, and if I can run 5 RPC, I'm actually scaling my RPC instead of scaling my whole support, instead of scaling my whole normal client, 5 RPC, 5 running separate 5 clients. So like get 1, get 2, get 3, get 4, get 5. It's not the case with one Erigon or two Erigon. You have multiple RPCs running separately, even locally, or as a report to that attached via mechanism like RPC, private API mechanism, which is I'll explain in the demo. So that's why RPC handler is very efficient. As I said in the it's a separate process. You can separate out RPC rather than having it Erigon. Basically, you can run Erigon on AWS. Now you have another node. This node you can give high CPU. You can have 10 RPC node and connected to single Erigon. All these 10 technically they are equivalent to 10 gets. You are having 10 RPC which are handling all your requests. But on the other side, cost of having 10 gets reduced to 1 Erigon. And your footprint also gets. And as I said, run multiple supports remotely. You can either run locally in the same machine. I have one machine, 10 RPC. Let's say that's not security perspective or not happy. You can run one Erigon and you can connect a remote RPC. You are running an Erigon and you expose the particular API with authentication. I myself can run my lab connected to your Erigon node which is running on some other server. So I don't have to run an Erigon node from scratch. If you have an Erigon node, you run one Erigon node, pass it to all your friends can run your own RPC even locally. They can local RPC even for the purpose. And in context, you just have to run one Erigon. Okay. And yeah, each starts compatible. I'll not go into detail as well. That's the advantage. I hope it's very clear. Using one Erigon, run one RPC attached. You can run one RPC attached. You can run multiple RPCs attached. So there are options available when you are actually running an Erigon. So the better one is obviously running multiple RPC. Quickly, chain supported by Ethereum, obviously Ethereum mainnet, Goerli, Polygon mainnet, Polygon Mumbai, Polygon chains, Shadow, Genesis, testnet. So yeah, Genesis and Shadow. These are the chains on which you can run your Erigon nodes right now. Unofficially, BSC is also there, but not the official repo. You will find fork of official repo created by people to enable BSC. Earlier it was there, but usually for that might find unofficial for Binance chain as well. This is the comparison. Now look at this number. Yeah. So it depends. I mean, I handle the Polygon side. I mean, I can sell for mainnet and mobile. I generally work, but only and all is on Erigon Foundation. I'm in touch with them. Whatever they I get a vote in saying mobile volume. So if there is actually leading the Erigon effort at the Polygon side, if anything related to mainnet and mobile, I'm not sure what their plans with Borley is. Yeah. But yeah, this is the numbers, guys. So if you look at the numbers, you will find how efficient the Erigon RPC node is. On Ethereum, if you get around 13 TVs archival node, that may be incorrect. Numbers might differ 1 or 2 TB here. But in Erigon, 3 or 4 TB, 2 to 3 or 4 TB, depending on your configuration. Okay. Similarly with Polygon, this is something I personally can show you right now. I'll show you some Polygon POS, both clients get booked out and created a book client. Our core client has archival nodes somewhere around 35 to 40 TB, 36, 37, 30, depending on your configuration. When you are running the same node with Erigon, it's 8 TB. Imagine that drop from 38 TB to 8 TB, saving around 75% of your storage cost when you are running Erigon compared to a normal get based node. And same reason I already explained in the staging mechanism, they don't store all the data. With the Erigon 3 which is coming, I'm pretty sure it will go further down. Use cases. Obviously, whoever block explorer, you guys might know. You guys might be there. We use block explorer. We can see as old block as possible. Block explorers are using archive nodes on their back. Block explorers. That's one of the basic. Everybody use block explorer. Everybody are doing transaction using Etherscan, Polygon scan, whatever scan. Check your transaction, whatever change. Your block explorers need archive to show you the older data. If you look at it, they show you all the transactions which are there. Even if you've done a transaction a year back or 2 years displayed. That is only possible because there are archival nodes running on. There are no archive nodes. Block explorer will not be able to work.
But most of the data is centralized.
But they are their own. I know Polygon can run their own archive node.
Is it like they have indexed data, right? Otherwise,
they have even if they are indexing someone or we cannot just touch other nodes. So for people as big as scan of Polygon better to run a couple of nodes and then indexing is done for faster retrieval. If they don't index, it will get slower. The data is not, it will get slow. Make it faster, they do index. Still, the data is provided by the archival. Indexer is not data something it's going to provide data far from archival. So only archival is there, then is there indexing. That's why the indexing. The node of the usage of RPC infrastructure. So again, use case indexing is tracing and debasing analytics. What has happened, which amount is doing what activity, what was the last activity. For any kind of analytics activity, security audit, you archival node, hold this older data and tracing, debugging, indexing, you need this data.
Node monitoring platform or something, node monitoring, like if I am running a Erigon node, right, I can get the details about how many years are there, like typical standard.
Yeah, there is. I can show you. There are it's open. I can share the link. For Polygon we have there is a stats. As I said, you see each stats comparable. There is a each stats dashboard. People can run. People as a Polygon run to website for I'll show you. So demo time guys, I'll demo. So this is the short URL link. If anybody gets it, they can take it right now. They can later as well, maybe in the Web3 app. Okay, so demo link is here. Not sure how much time to handle. I think that is enough time. So might not be able to show you can just copy this link. With this link, what I have done is I have actually explained how you can sorry, it's still not visible. Visible now? Is it visible? I'm not sure. I'm not able to see from here. I'll share the link with guys. Let's do one thing. Just copy this link, short link. It's also not visible. So I'll just type surli.li. surli/JZXZXDU. Anybody able to open it? maybe I can share after that. Okay, so what I've explained here is how you can basically know Erigon, know the basics, check out the latest version. Now you can build, you can start your own node, very simple command. Like for example, if I want to run my node on mobile, command here, start my web node. And I think Mumbai nodes usually start from scratch. Takes around 400 to 300 GB. So if you have a 1 terabyte hard disk, you can simply run it in a local. Like if you have a 1 terabyte laptop with SSD, most probably, but with hard disk you can run it. Mumbai is like doesn't have that much depth. Only they have less data. Mainnet, Polygon, or they have more data. That's why they take things. If you run Polygon, mainnet is 8 GB and Mumbai mainnet is 3 GB. So I've explained few details here. Sorry, you guys are not able to see. So I've explained few nitty-gritties, like if you want to do this, the lines actually mention you to do this, you have this flag, you have to do this, you have to, like for example, if you want to run, you want to get your own EIR, if you want to change from this second to the second, how you can run your RPC handler, and all. So guys, I'm running short of time, most probably it's better that you guys, I'll share the link, and I have a couple of things as well to show. So I'm not sure how to share because whatever I'm sharing, I'm not able to. Maybe what I'll do is Okay. I'll do something. I'll post in the group. Sorry. I wanted to show you notes as well, but sorry, it's not visible. I'm not visible. I don't know why, but I have a couple of Erigon nodes running here. You guys can see. So these are my internal Erigon nodes running very efficiently. It's ignored. So nothing is visible. I'm really sorry. So what I can suggest to you guys can go to this repo. Erigon repo. Search Erigon on Google. Erigon repo. They have the state thing which I told you in explained properly with diagrams and which stage how much time and everything. You also you get more details about how to run multiple RPC demons and everything. Also mentioned what are the key features, what are the plans that are coming up. There is also a Erigon with Erigon. But yeah, even the review is fine. You were asking for that some monitoring. So we have this kind of platforms actually. Show you.
Something like a beacon chain app, you might be knowing what which provides the stats about like over the phone I can see how my node is going, like whether any client. I don't see support for the beacon chain app for the area, but Nethermind and all that.
In the mining it. Mining it.
Not mining. Like Ethereum mainnet.
I'm not sure if beacon chain will provide you all that. Does it provide free archive node as well? Erigon, I personally know Erigon at least not sure. Let's say Erigon, but at least 10 to 20 nodes are there for Erigon.
Not about the whole network. I'm looking for something for my network. Like for example, I'm supposed to take a bunch of mods on Ethereum using various clients. Right? So I wanted to see like how many players are connected to my Rock 5 or ARS.
See, I'm not sure for Ethereum, but all this kind of dashboard.
Yeah, that's what
okay, so yeah, we have this. So if you have, for example, if you look at this node is an Erigon. I have multiple. This is one of the Erigon node. Sorry, it's not visible. But here I can see the peers right now. It is on this block number. The last block. Like this, you can see a lot of everything is the node type, the peers, block number, the difficulty, the timing, and everything. The last time. So we have this kind of. It's a public dashboard. It is whole.Mumbai.com. I can share the links. Most of the links are not visible very clearly. Okay, any other question? I think that's demo. I'm sorry, but I'll share this Erigon demo. Blog covers everything regarding demo. That's all the things you need and some reference links in the last as well. Like Erigon. So yeah, I think you can do demo by yourself.
You have stats for the full node, like archive node, but I think most of people will be interested in running the node over like a full node, right? You had said how much RAM or memory, what kind of.
Sorry, I don't have right now. I don't have a presentation. So, for example, if we compare Polygon, let's say or Midnight, so RAM and all initially, if you provide more RAM, it's not like that. If you provide 16 GB or 26 GB, it will say my since the data is more, I mean, it will take more than a month to sync. If you more than a month, yeah, literally. For a full node, it's really less. I mean, look at the RAM alone, 16 GB RAM is enough for a full node. And the data gets used by 90%. Like our archive node, like for example, your archive node at 40%, it's hardly gone on to I think it's around that. It's very small. It's very small. No, it's less than 800. I'm seeing quantity. Reason it's less than that. It's less than TV. I'm pretty sure the reason behind it's deletes always proven like it's like a continuous cycle. The more it's running, like let's say I have a block 100 and I have a limit of as soon as I do one, I delete the block 102, I delete the block. So I'm always have 100 blocks, recent blocks in my memory. That's what my data footprint doesn't take. Even if I'm adding anything, I'm deleting something. That kind of doesn't increase by that much when you're running a full solution. Full node. At least 3-4 days, right? Sync from scratch. See, we have reached a number of 40 million plus. Very hard to say. I can say. Polygon, we have more than 40 million plus. We generally don't check from scratch. We actually take snapshots from site. We have a website, official Polygon website. You can download a Polygon snapshot from there, and that snapshot is provided by us, our DevOps team. Using that snapshot, you can update your node up and running in a day. Within a day, if you start in the morning, download the snapshot, couple of hours, extract the snapshot, start your node, and it takes couple of hours to reach the 24 hours you will reach to the top. But if you start from scratch, it will take around 5 to 7 days. Okay. This is last slide I also had to show. So yeah guys, that's I'm sorry. I had enough time. Feel free to reach out to me after the session as well. I'm here for 3 more days. My session is also done, but I'm gonna enjoy with you guys there. 10 more sessions. Okay. Any other questions? Thank you.